Nowadays, India is facing huge unemployment problem. Each year, about 1.5 million engineering graduates pass out. But out of that 1.5 million, only 10% of them will get a job in 2023. India is having more than 2500 engineering colleges, 1400 polytechnic and 200 schools of planning and architecture. Still we are facing this unemployment problem. Why? Because students don't have what industry wants. But exactly what industry wants? Industry wants people who can do simulations. Industry wants people who can understand basic concepts. Industry wants people who are flexible to learn any software that is needed for that industry. So how can you achieve these concepts, and why current education system is not able to deliver this to the pass out graduates in engineering? For that we need to see what is lacking in our education system. First is simulation is not given that much importance in the academics. So whenever we are taught simulation in our engineering classes, we are made to follow just some practical things which are predefined in the labs. Generally, students copy each other practicals or seniors practical and just they pass out. But they don't understand what is the importance of that simulation, how that simulation is used. They just consider it as a software which has no importance at all. In education system, we need to put stress on simulation, how an engineer thinks and do simulations, that they need to understand first. Second things is practicals. So in engineering classes, most of the times practicals are performed before the theory is completed in the class. So student doesn't know the theory, whatever practical he or she is doing. So how can they comprehend the concept if they don't know the theory? Third is practicals are not taken seriously. So generally, if you see in machines class, there are groups of students doing a single practical. So out of that group, only 1 or 2 students will do the practical and rest all will follow. So in such cases, how can we expect that everyone understood the concepts and have done the practical seriously? So seriousness of practical is much needed in our education system. Fourth is simulation softwares are very expensive, and to learn the simulation software, it is a bit of a learning curve. Simulation software teaching should be started as early as possible in the engineering education so that the person will get 2 or 3 years to explore the software and use it for their understanding of the concepts. Fifth one is the fear of coding. So most of the students in other than CS and IT, they fear of coding. They think that coding is very difficult, it is not for them and it is not useful in their field. But actually coding is used everywhere in engineering. So not only electrical but also mechanical, chemical, electronics, everyone should know coding. So as a student, what can you do to overcome this lacking in your education system? Education system cannot be changed just like that overnight. So you as a student has to do something so that you overcome this. And once you overcome this, you are ready for the industry. Then any industry can hire you. So to solve these problems, I am making series of these videos so that you as an electrical engineer or any engineer should learn the basics of MATLAB or any simulation software. I will mainly focus on the concept of how an engineer thinks of a problem, creates a simulation and then implements it practically. I will teach you how a problem solving engineer should think. So this is the theme of making these videos, and we together will solve the problem of unemployment in India. I guarantee you that if you follow along with this video, you will definitely get job as soon as possible. Just stick with the video, understand the concept and implement it. You will be ready for the industry. The theme of our video is, first we will see a little bit of theory and then we will implement it in the simulation. This series will be part of electrical engineering. I will cover many concepts of electrical engineering in this series and I hope you will get along with it and be strong with the basic concepts. So in electrical engineering, we say there are two types of currents. One is AC and one is DC. So AC, what we call it as alternating current, and DC, what we called it as direct current. So how can we understand this concept? What is AC current and what is DC current? So we will understand this with a very practical point of view. Suppose you have a socket. So in home, there is a socket or 3-pin plug. So what here, this 3-pin plug, what you get? You get a AC voltage. And suppose there is some other plug, there are two terminals here. One is positive, one is negative. So here we are getting DC voltage. So in AC socket, what are these 3 pins? So this above one is earth and below two is one is phase and one is neutral. What we will do is we will put some kind of measuring instrument here. So what this instrument does is it will show us what time of waveform we are getting at this terminal. And similarly we will do, so this is some measuring instrument. Now here if we see, this is the screen of that measuring instrument. So what we will get? We will see a waveform that is oscillating along the x-axis. So what is this? This is the voltage waveform which we are getting between the P and N terminals. Similarly, if we see it here, what we will get? Will we get a waveform? No. We will get just a straight line. In the DC socket, we will get just a straight line, and in the AC socket, we will get a alternating waveform, or in terms of mathematics, if you see, this is sine or cos waveform. Correct? So here, this axis, the x-axis, this is the time axis, and the y-axis, this is the amplitude. So amplitude of whichever quantity. So here, what is the quantity on the y-axis? It is the voltage. Here it is AC voltage and here it is DC voltage. So this is the maximum AC voltage and this has a frequency. How do we define this? We define this VAC as Vm. Vm is this point sine omega t. And what is omega? Omega is 2 pi f. So here f is the frequency. So what is the frequency in India? What we are getting? It is 50 Hz. So this alternating waveform is with 50 Hz. And what is the voltage which we are getting? We are getting 230 volt. Correct. Similarly, DC doesn't have any waveform. It just has a amplitude. So this amplitude will be whatever voltage we are getting here. It may be 10 volt, it may be 20 volt, whatever voltage it is here. Okay. So whenever you put a load across this terminals, then current will flow through it. If you put load to the AC voltage terminals, current will flow through it, and we called it as a AC. And when you put load to the DC terminals, current will flow through that load, and we called it as a DC. So this is the basic concept. Now let's turn out to our simulation and let's see how this AC current and DC current looks like. So for simulation, we are using MATLAB software. MATLAB is the matrix laboratory. So here each and every variable acts like a matrix and we can do very huge computations using this software. This is called the command window where we can write commands. But for now, we will work on Simulink. So Simulink is a part of MATLAB. In Simulink, we can do simulations of different electrical systems. So what do you mean by simulations? So suppose there is some engineering problem. Now you want to find the solution of this problem. So suppose you want to run a motor at a particular speed. So you want to do speed control of the motor. Now there are different methods for doing speed control of motor. And to do this speed control of motor, you will need some kind of hardware. Okay. Before, what people used to do is, people used to build a prototype of the problem which will be small in size, and if that works, then they will go for production or for the final product. But nowadays what we do is we will simulate it. What we will do, we will use a software, we will create the hardware inside it, we will have a mathematical model of the motor inside it, we will have the control inside it, and all this part we will integrate inside the software and run the simulation. What do you mean by running the simulation? We will see exactly what outputs we are getting based on of our model, and if there are some changes, some problems, some difficulties we are finding in the logic of our speed control, in the hardware part, then we can change it itself in the simulation. What this thing does is it will accelerate the development of the product. We will find most of the errors before we actually build the hardware. This will not only save the time but also money from the perspective of industry. Okay, I hope you are getting what simulation is. So let's see practically how we can do simulation. So in MATLAB, this is MATLAB Simulink. So here we will create a blank model. So click on create model. Once this blank model is created, we will add elements what we need to do. What we need to do, as we have discussed here, we will create two types of circuits. One is AC circuit with the load, one is DC circuit with the load. So this is a MATLAB environment. If you see, here is a library browser. So go to library browser. So here go to Simscape first. Inside Simscape, go for specialized power systems, and inside that sources you will see, and inside sources you will get AC voltage source. So this is your AC voltage source. Second thing what we want is DC voltage source. So this is the DC voltage source. So we want some kind of load for this system. So from where we will see, we will get it from passive. So inside specialized power system, go to passives, and inside that we can get it from here, the series RLC branch. Just drag it. So this is series RLC branch. Double click on it. From here branch type, just select R because we want only resistance. Then put the value as 23. Then apply. OK. Now you see the symbol has changed to only this resistance part. We can name it as resistance 1, or better resistor 1. We can copy this and paste it here and call it as resistor 2. We will call this as resistor 2. Now we want to rotate this. So right click, format, rotate counterclockwise, or shortcut Ctrl R. Here also Ctrl R. And now we need to connect this AC voltage source to this resistor, and we want to measure the current going through it. So for measuring current, we want some kind of meter. So that meter, it will be current measurement. So we can search here current measurement, and here we get current measurement. Just drag it similarly to the AC measurement. Now connect from AC voltage source to this current measurement, and from this current measurement, the second line, the below one, connect it to the resistor. From AC voltage, drag this line to the resistor. Similarly do for DC circuit. From positive to here, from negative to here, and from negative to here. Now this is a current measurement. For watching what is inside this current measurement, we want some kind of scope. So that scope we will get from Simulink, Sync, and Scope. Drag this here and here. Now connect from here to the scope and from here to the scope. And that's it. Our circuit is ready. Only here the resistor value, we will change the resistor value for the DC circuit to 20. Now practically we have two types of circuits ready. One is this AC voltage source and one is this DC voltage source. Okay. So now for running the simulation, what we will do, we will click here the run button. And before running, we need to see what is the stop time here. So here stop time is 10 seconds. That means this complete simulation will run for 10 seconds and then it will stop. So just go write it here as 10 seconds or whatever time you want to give. Suppose we'll reduce it to 5 seconds. Now before running the simulation, we want to give the voltage value. So here we can give the voltage value as suppose 100 volt and frequency as for Indian frequency is 50 Hz, so we will give 50 Hz. And here the DC source value, the amplitude is 100. Okay. Now we will go and click on run button. Now simulation has run, but there is some kind of errors. So it is saying the diagram must contain power GUI block. Okay. So we forgot to add one block that is called power GUI block. So go to library and search for power GUI. So you need to remember whenever you are running this kind of electrical simulation, you need to always add this power GUI block in your simulation. Okay. Now just go and run the simulation. So what is expected now? If you see here, this is for the AC voltage source. So double click on the scope. So you are getting some kind of waveform. So what is this waveform? This waveform expected is for current. So whatever current is flowing through this resistor or this circuit, that should come here. So something we are seeing here, but we are not able to see it properly. So to adjust this, go to here, then click on this. After that, go to this zoom button, then click on here. Then with this button, you can drag along x-axis. Okay. So here if you see, we are not getting waveform, we are getting some kind of sawtooth. This is not what we have expected. Okay. So there must be something wrong with the simulation. So in order to correct this, we will change some kind of settings here. Okay. So to fix this, go to model settings. Model settings you will find in modeling, model settings. Inside the model settings, change this type to fixed step, change the solver type to discrete and give fixed step size as this 0.50 then 1. That means 1 microsecond. Apply it and OK. Now go to simulations and run the simulation. Now click the scope. Now if you see, we are getting a sine waveform. Also, I have changed the simulation time to 0.1. Now we are able to see the waveform clearly. So this is the current waveform. So for AC circuit, we are getting AC current. And this is the AC waveform what we are getting. Similarly, for this DC circuit, if we open the scope, what we are getting? Okay. So here we are getting a line at 5. That means this is a DC current at 5 ampere. So why it is coming as 5 ampere? So as you know, the DC voltage source we have given voltage as 100 and resistance as 20. So 100 divided by 20, what we are getting is 5. So 5 ampere is flowing through this. So I hope you understood that in AC circuit, the voltage itself is AC. That's why we are getting AC current. And in DC circuit, the voltage itself is DC. So we are getting the DC current. Now, how you will determine this current value? So what is the relation between all this: voltage, resistance and current. This relation remains constant whether it is a AC circuit or a DC circuit. So here we comes to our first law in electrical engineering. So that law we call it as Ohm's law. So what Ohm's law says is, mathematically, theory you will learn in class, but here we will see it conceptually. So mathematically, voltage is equal to current into the resistance value. So suppose if voltage value we give it as 200 and the resistance we give it as 5 ohms, then the current flowing through the circuit will be 100 ampere. Okay, so this way the Ohm's law works. So if we see practically in our circuit, what we have done is, here the voltage is 100 volt and resistor is 23. So 100 divided by 23, how much? 4.3 something. So if you go in scope and see the waveform, the max value is going above 4 point something and below also minus 4 point something. So this value we are getting. And in DC circuit also, if you see, the amplitude is 100 volt for the DC voltage and resistance is 20. So voltage 100 divided by resistance 20, we are getting as 5 ampere. So in this way, practically we can check whether the Ohm's law works or not. I hope you have understood this basic concept and basic simulation. Not to give you that much load in terms of simulation, because this is a new software for you. So go open this software. If you are in first year, get this software, install it, or ask your teachers, faculty, school or college to get this software for you and follow along this video. Create as many circuit as you want. You know where to make the circuit, how to make the circuit. I have explained everything in this video. Go make as many circuit as you want and see whether Ohm's law is being followed in all your circuits. And if you have any doubt, you can ask in the comments regarding any electrical concept. If you are not getting something in this software or you want to create something, just write it in the comment. I will respond to it as soon as possible. Thank you.